So this video refers to Lecture 2 forces, and specifically resolving forces into I and J components, and then finding a resultant force when you have several forces that you're looking at. So just as with the parallelogram rule earlier, we made two forces into one, we can also take one force, we'll call that F, and we can resolve it into its X component and its Y component. It's meant to be a Y, sorry. What we can then do if we have several forces is we can say take all the X components and add those together, all the Y components and add those together, and then find a resultant force, but I'll show you that in a moment. We can also use Cartesian notation. So Cartesian notation is referring to I's, J's and K vectors. So that's my x-axis and that's my y-axis. The I vector, that's meant to be an I, goes positively along the x-axis, and the j vector goes positively along the along the y-axis. So for instance, this force here, that's a Cartesian vector, has a magnitude fx in the I direction, and it has a magnitude fy in the j direction. What we can then do is we can take several examples, several forces, and add them together when we found the I and the j components. As an example of that, if you turn to the first example question in your lecture, slide 15, we'll have a look at that together now. So, slide 15, you have a question: three concurrent forces acting on a tent post. Find the magnitude and angle of the resultant force. So if I just draw the diagram that you've been given. So the first thing you do is write each of those forces, F1, 2 and 3, as a Cartesian vector. So if we do that first, force 1 is only going upwards, so it's only in the j direction. So it's 0I plus 300j. Force 2 is in both the I and the j direction. So using trigonometry, it's 450 cos 45 I plus 450 sine 45 j. And because it's going backwards in the x direction, because it's pointing in the negative x direction, we put a minus on the I part of the vector. And force 3, using the small triangle that denotes the ratio of how much it goes up in the x and the y, it's moving 3/5 of 600 in the I, and it's moving 4/5 of 600 in the j. And what we can then do is we can add all of those together. So our resultant force, it should all have been underlined, sorry, because these are all vectors. Our resultant force is then going to be 0I plus 450 cos 45I plus 3/5 of 600I. And if we add those together, we get 41.8I. not forgetting that the middle vector was a negative I. And then if we add all of our y or j components together, then we're going to get 1098 j. So that gives you the resultant force, one force as a Cartesian vector. If I just clear that and clear the screen, I'll show you what to do next. So we had 41.8 I plus 1098 j. To find our overall magnitude, the size of the resultant force, we then say Fr, and this is not underlined because it's not a vector, it's the magnitude of a force, how big it is. We'll do 41.8 squared plus 1098 squared, so the x and the y components squared. Square root all that, so Pythagoras, and we'll find the resultant force should be approximately 1099 newtons. The direction, so if you imagine it's going fairly high because there's a lot of y component and not much x. That's your x direction. This angle in here, which we'll call phi, is going to equal, using trigonometry, the inverse tangent of 1098 over 41.8, which equals 87.8 degrees. So this video related to Lecture 2 forces, specifically resolving vectors into I and j components and then adding several vectors and finding the resultant. You should now be able to do the next example yourself if you want to pause this, and then I'll go through it in the next part of this video. So you should now have had a go at the group problem solving task, which I believe is on slide number 19 of lecture 2. If I then talk you through it, you should have a diagram that looks something a little bit like this, maybe a little neater. So the first thing we do is resolve each one into its I and j components. So force 1 is equal to, in the x direction we've got 800 cos 60 I, and therefore we've got 800 sine 60 j going upwards. Force 2, we're going to have 600 sine 45 I, and again that's going backwards in the x direction, so that's going to be a minus, and it's still going upwards, so we're going to have 600 cos 45 j. And force 3, we're going to have in the x direction 12/13 of 650 I, and because it's going downwards we've got a negative j of 5/13 of 650 in the j. So the next thing we'd do is we'd take all of our I components and add them together, all of our j components and add them together, and we should come out with a resultant force, a resultant force as a vector of 575.7 I plus 867.1 j. So now I'll just clear my board and then show you the next step. So our resultant force was 575.7 I plus 867.1 j. So the magnitude of that force is going to use Pythagoras with the I and the j components. So that should equal 1041 newtons. The direction that it's going will then be the inverse tangent, of 867.1 over 575.7, which is 56.4 degrees. So that's the conclusion of adding several vectors to find the resultant in 2 dimensions using Cartesian vector notation. That refers specifically to Lecture 2, slides 10 to 19.